Hi class, this is number 5 on the chapter 12 practice test. Says the iPad Touch has been out for 2 years now, and a lot of data has been collected, relevant relationship. There is a functional relationship between price and an iPad Touch. P is the price and weekly demand S. Okay. So, and this is real life, you know, obviously there are iPads out there and there are prices of the iPads, and when you look at economics and you get into those types of fields, you do data like this. So they give us this table, and then they say, find the linear relationship that best fits this data using regression and enter the model below. Okay, for entry, round the linear parameter value to 0.01 and constant parameter to nearest 1. Okay. So I just entered all this data into my class calc at this website, classcalc.com/graphing-calculator, graphing-calculator. Okay, so let me just show you how I did that. I would have just clicked here, and then I click on these 2 double arrows that open up, and they go stats, advanced, and then I go to linear regression, and then this first column, all the things in that first column, the first variable price, I put in this first one. So like I think it's like the 150, 170, I think 190, and so on. I think those numbers I put in that first column, and in the second column, 216, 207, and 194. 216, 207, 194. I think that was the numbers. Okay. But I put the whole list. So that's just a little example. If I just put the first 3 in the first column, and first 3 in the next column, but I did all the numbers in. Okay, so I did that, and then these are the answers I got. So here's your line. And so they said round the linear parameter value. I believe they're talking about the slope here, the slope value. And then the constant, well, the constant is this term right here. So I believe they want that just rounded to 1. So they're probably going to say negative 0.43 x plus 279. So yeah, that's exactly what they want here. Yeah. So when they say the linear parameter around the linear parameter value, they're just talking about the slope in the line, you know, the coefficient on the x term. And then the constant parameter, they say around to the nearest 1's place, that they just mean the constant term of your line. Okay. All right. Okay, then the squared correlation coefficient, R squared, and it is 0.95, and it is above or below 0.95. So it's actually above, it's tiny bit above. So if you just press above here. They say values less than 0.95 may mean the model is not appropriate for making predictions. Okay. Now to 2 questions using the unrounded model and parameters. Okay. What does the model predict will be the weekly demand if the price is 171? So they don't want us to use this version right here. They want us to use all the decimals. They want us to use the 0.431429 when we do our calculation for this. But to find this answer, basically this line, it has 2 unknowns, the y and the x. And when they give you here an x value, because your x values are the price of the the iPad. So they give you a price. So we're going to plug that in for the X. And then we're just going to simplify and find out what the Y is, because they're asking, if given this X value, if X equals 171, what is Y, right? That's what they're asking us, because the Y value is the weekly demand and the X value is the price. So they say find Y if X equals 171. It's the same question that they're asking you. So, and they don't want us to round anything, just keep it nice and accurate. So let's write it down here. And I want to keep all those, but I'm just gonna, times 171 plus the 278.619, right? So let's do that calculation. And we follow order of operations. We plugged the 171 in for X, and we follow order of operations. So we do 171 times the value there. So 171 times, and I'm going to write that whole decimal out, negative 0.431429. Okay, I get an answer there. Oh, I did 2. Careful. Negative 0.431429. Okay. Okay, now I'm going to take that answer and I'm going to add the, and maybe it's better if you put this in parentheses. Okay, and then we can just add on the 278.619133. And there we go. So we get 204.84. And let's see how they like that answer. 204. Oh, in the thousands. So they want us to write this back in thousands. So if you multiply that by 1,000, then it's going to get the decimal. It's going to move it 3 places. So that's why they're getting the. So we got 204.8447. And they want it rounded to the nearest 100. So you would have moved this decimal 3 places, 1, 2, 3, and then round to the nearest 100 would be the 800. So that's just be careful here with this problem, because we do need to remember that this is in thousands. So when we present our final answer here, we wanted to multiply that by thousands. So that's what happened there. Okay. All right, the next part. According to the model, at what price should be set in order to have a weekly demand of 275,200 iPad touches? Okay, so this is backwards from the original problem. So we have an equation, y equals I'm just going to put the truncated part. Our equation looks something like this. And we have 2 unknowns. And what we can do is if you're given either unknown, either the X or the Y, then you're able to solve for that other unknown. And in this part C problem, you were given the X, so you're able to plug in for the X, and then you were able to figure out what Y was because you knew the X. So in this problem, they're giving us the weekly demand. So if we look up here, that weekly demand this is our Y. And this is our X. So that's the Y value they're giving you. So we're going to be plugging that in for Y. The 275 And I believe we do not want to, we want to plug it in as in thousands. So the 275.2. Because this is the actual number that, but when we're plugging into the formula, we're writing it in the number of thousands. And then see, once we plug in for y, now I have one equation and only one unknown, and I can use algebra to now solve for that. So now what I would do next is I try to isolate the x term by itself by subtracting 278 for both sides. Then I would do 275 minus 278, which is, okay, it's 0.8 to 6 and then 2. So 2.8 right? Because if I add 0.8, then I'll get to 276, but then I add 2 more and to get to 278. Okay, 2.8 equals 0.03. And here's where I need to probably keep all those decimals. They said keep all the decimals, right? So 3, I think it was 129, something like that. X. And then we're going to solve for the x by dividing on both sides by the coefficient here. Oh, and it was negative 2.8. Ooh, something that we have to really be careful about here when we're solving these problems is we wanted, there's two numbers here, the 278 and the 275.2. And we just have to we have to ignore all the signs and just look at the positive numbers and just take the positive number, the largest number, and subtract the smallest number, which is what I did. But then you have to keep the sign of the larger number. So this is negative 2.8. And then now we divide by negative 0.4312 on both sides. Okay, sorry about that. Okay, so we just divide by that coefficient on both sides, and then we're going to find, and something I did not realize, I noticed right now that I took the truncated version of this number, and I think they're probably not going to like that. So I should probably back up really fast here, and this is 278 should be the actual number. So I'm going to go back and find that actual number. So it's 278.619133. Okay, so it's 275.2 minus 278.619133. Okay, so that's a little different. It's not actually 178.61. Okay, so it's 4.3. So this number, okay, this is 275.2. This number right here should have been, let me just back up and correct it, just so we get this answer absolutely spot on. We have 278.619133. And we were subtracting that from both sides. So minus 278. It's just not convenient when you're doing algebra to keep all these decimals. So that's why I just wanted to get rid of it while I was doing that. But okay, here we go. And now I believe I wrote out probably the almost full case, 0.431429. Okay, so I have one, I'm missing one. Okay, so now I think I think we're as accurate as we can be here now. Divide by negative 4, 3, 1, 4, 2, 9. And we'll double check the answer. Sometimes I feel like you really have to have your whole heart on it. You really have to be totally focused. And if you have this mindset when you're doing math, I just want to do it fast. I just want to get done. Like, I'm a little lazy. I don't want to, I don't want to write out every step. Like, that's what's going to cost you the problem. So you've got to allow yourself plenty of time. You've got to be kind of patient, take some deep breaths to be like, not be in such a rush. So I feel like that's when I'm in a rush. I mean, I almost forgot the negative sign on 3.4, which is a big major, thing. And that goes to show you guys that you really have, when you're doing these algebra problems, you really have to pay attention closely to your negative signs, because one negative sign could really throw off your whole problem, really. Okay. Oh, one more thing. Let's calculate now. What is 3.4 or negative? Oh, wait. What I can do is I can just do this answer. Let's put that in parentheses. That way I can keep that answer still in there. And then now I can just say divide that whole thing by the negative. I'm gonna put the 0 in there just to remind me, so I can see clearly that it's a decimal there. 29. Okay. Did I have 431, 429? Okay. And there's our answer, 7.925. So and that is. So let's check it. Yep. And so they rounded it to the nearest ones place. I got 79, and their answer is 8. Nearest dollar. 8. Yep. 8. And we got that one. And there we go. So there's a few hiccups with this problem. You have to make sure that when you're working and you're plugging in variables as y or x, make sure to plug them. If you're working with a y, we had to make sure to plug it in thousands, and we didn't plug in the answer as we see it in the problem, or the problem. And we also had to remember when we get a y value that it's written not in thousands. Well, it's written in thousands, and we had to multiply by thousands. So that was a little hiccup with this problem. But hopefully you found this very valuable and easy. Have a great day. Bye.